morning, 5th grade. Coming to you from the Deek STEM Labs. We wanted to make sure that you could stay up on your STEM lessons. And since you guys have been working on states of matter, the next topic for you to work on is conductivity. Now, I think your teachers might have talked to you a little bit about it last week before we left for the break. I'm going to do a demonstration for you. Your teachers should have in your Google Docs a worksheet for you to work on. And I'm going to do the lab right here in front of you, and that way you can kind of fill out the worksheet as we go along and then resubmit it back into your Google Classroom so your teachers can see that you've been working on your lessons from home. Now this is one you can do pretty easy at home if you have a few things available to you, and I'm going to go over how to set this up in case you want to do it at home. So one of the things you're going to need to make first is a very simple probe, so that we can test whether or not something is conductive. So what I have here is a 9-volt battery, and I actually have a 9-volt battery hood on this one. Now you can find this if you have an old toy, you might be able to cut it out, but make sure you make your wires nice and long. And then I have 2 popsicle sticks that I've actually wrapped in aluminum foil, and believe it or not, a light bulb from Christmas trees lights. Now I had an old strand of Christmas tree lights that weren't working anymore, but I cut the bulbs off, and you can see I cut it so that I had the long wires, and this actually makes a great bulb for testing in this particular case. And then I used a wire nut so that I could connect my battery to my light. So if you'll recall, last year we worked on circuitry, and right now I can't have any energy going to my light because my circuit is not complete. I have a big gap in here. My energy can't travel from my battery all the way through to create energy in my light. However, if I touch the 2 probes together, I can get my hands to work here. If I touch them together, I can complete that circuit and I get energy going to my light. So I know this works. Now, what we want to test today is the conductivity of water. And what I have here is I have a cup of actual, just regular spring water. I have 3 ounces in this cup, and I have 3 ounces in each of my additional cups. What I did in the other cups is I added salt to them. Now you can use table salt. I like to use Epsom salts because, and this is the kind you'll use in the bathtub. I like to use these because they dissolve really easy, and it made the experiment a little quicker to do. Now I've already went ahead and dissolved the salts. So in the first cup, and you'll need to mark this on your chart, this would be S1 salt, and this has a half a teaspoon of Epsom salts. In S2, I have a teaspoon of Epsom salts. Now I've already dissolved these, so that's why it doesn't really show up too much. And then in S3, my third cup, I would have a tablespoon of Epsom salts. Again, it's dissolved so you can't see it in the water. Now what I want to do is I want to see if the amount of salt in the water has an effect on how conductive the water is. But I don't know if this water is conductive in the first place. So the first one I'm going to test is my cup of just plain water. So I'm going to take my probe, and I know that this works because I've tested them together. My light's very bright. Let's stick them into the water, and I want to make sure my probes don't touch. And guess what? No light. Spring water does not conduct electricity. Now that's not to say if I dropped a hairdryer in a bathtub that it wouldn't shock you, which would be highly dangerous. Never do that. But in this case, the amount of spring water I have doesn't conduct any electricity. Let's do it again. I saw my light light up, but it was because my probes touched each other. So you can see, probes are far apart, and there's no conduction of electricity. So I'll take those out. Let's set that one off to the side. The next one I'm going to test would be your S1 cup, and that is going to have the half teaspoon of salt. So let's test for conductivity. So my probes are far apart, and I don't know if you can see it, but the light is lighting up. It's not very bright, but yeah, it's conducting some electricity. Interesting. That's our half teaspoon of salt. Now let's move that one out of the way, and let's look at our full teaspoon of salt. Let's see if that conducts electricity. In we go with our probes. Oh, yeah, I can definitely see that light. Now that's twice as much salt and the same amount of water. And what do we notice about the light? Okay. Now the last one I want to test is my tablespoon of salt. Same amount of water, tablespoon of salt, so that's more than double. And we're going to test. In go the probes. And I think I burnt my bulb out. Yep, I burnt my bulb. What do scientists do when the bulb burns? They stop the video and replace the light. Give me a minute and I'll be right back. Okay, so one of the nice things about using the Christmas bulbs in my tester is I have an extra bulb here from the strands, and I'm going to assume this bulb is good. Let's see if I can get it out of its holder, because I can take this bulb, pull the burnout bulb out. Now remember, I'm using a set of old Christmas lights, so they didn't work in the first place, so if I burn all these bulbs out, it doesn't cost me anything. Alright, we're going to really quickly test this bulb. If I hold it together for too long because I'm using a 9-volt battery, it will burn the bulb out. But let's see if we have a connection. Oh yeah, very bright. Oh, and look. I lost my wire nut. Let me grab that. I want to make sure my connections are all good on my tester. Remember, this is a homemade tester. This isn't something you buy at the store. Alright, so I believe we were down to S3. That's the cup with 3 ounces of water and a tablespoon of the Epsom salts in it. So we're now going to use our probes and we're going to test for conductivity in this cup and see what we get. You get nothing. Oh, wait. Oh, interesting. Is our light brighter or dimmer than cup 1, cup 2, and cup 3? That's my question to you. Now I have one other thing I can test here, and that is going to be using baking soda. So I also have some cups here of baking soda, and I have pre-dissolved in 3 ounces of water the same amount as I had dissolved of the salt. And these cups would be marked B1, B2, and B3. I just have to remember which order they were in. So the next thing we're going to do is we're going to test baking soda mixed in water. So I again have the 3 ounces of water, spring water, just like before, and in each one I've dissolved baking soda. So I would have B1, B2, and B3. And we're going to test to see if this substance conducts electricity. So the first thing we need to do is use our plain spring water, and we're going to test, because we know that's our control, we're going to test for conductivity. And obviously we get no light, so we don't have any conductivity there. A quick test to make sure that our bulb is working. And we know that's working as well. So here we go. So this would be B1 for baking soda. This would have a half a teaspoon of baking soda in it, and it's a little hard to see, but the light is really, really faint. Now I'm going to go into B2, and this is baking soda with a teaspoon of salt in it, or baking soda in it. And again, it's faint, but the light is just a tad brighter. Possibly you can see it this time. And then the last one we have, baking soda doesn't dissolve as well in water, so if you look, if I use my fork here and I stir, you can see that it hasn't all dissolved and that there's still baking soda in this cup. So you can see that in there. And this has the tablespoon. This would be your B3 cup. And we're going to test. And there's the light. And yes, possibly a little brighter than cup 1 and 2. This is B3. This is the tablespoon. And yeah, I think it is a little brighter. Okay, so we can still see that our probe works. Our light's very bright. All right, so we've done that. I hope that you have filled out your chart you found on the second page of your conductivity lab sheet. Right now I'd like you to take a couple of minutes, turn the video off, write an observation of what you saw happen. Look at your graph that you completed here, or your chart that you filled in. Kind of draw some conclusions, and write a quick little observation that you can share with your teacher. Remember, I'd love to see what you're doing, so if you want to email them to me as well, or I can get them from your teacher, I'm excited to see what you guys are doing. Okay, I assume you've turned the video back on at this point, and I have a couple other questions for you. Could you figure out a way to graph these results that you found here? And if so, what would be the best type of graph? If you think you have a really good one, that would be a great extra feature that you could add to your Google Doc. You could probably do a quick graph on the back. I bet your teachers would love to see that. You might be able to find a way to actually even do a graph in Google Docs that you could share that information with your teacher as well. I'd be very curious to see what you come up with there as well. And then finally, I want you to answer these last questions. And the first one is, does all water conduct electricity? Now, what do you think? Did the spring water with vanilla additives conduct electricity? Did the amount of solid added to the water affect the intensity of the light? In other words, based on how much of the baking soda or the salt we put in the cup, did it have an effect on how bright the light got? I'd like you to answer that question. And then the last one is, using the knowledge that you've gained today, consider large bodies of water like an ocean or sea. Knowing that these are made of salt water, what happens when lightning strikes them? It's an awful lot of amount of electricity hitting salty water. I want you to research and add your answer in your own words of what happens and what the effects may be on the ocean and the sea creatures. I look forward to seeing you soon. Remember, wash your hands, don't touch your face, stay healthy, and we'll see you in the lab real soon. Have a great day.